Let's look at another similar one here. This time I want the area bounded by f of x equals x squared and g of x equals square root of x. This one's pretty tricky to graph. This one you would probably need a graphing calculator for, or I think Desmos would be a really helpful tool for you to use. I'm going to go ahead and sketch this in. So if you were to look at y equals x squared, you would see a parabola which opens upward, and actually I'm going to exaggerate the features here just so that I can see the area a little bit better. So this is f of x equals x squared, and then g of x is square root of x. Now if you graph it on your graphing calculator, you're going to have a hard time seeing it at first. You will have to zoom in a little bit, but when you zoom in, you'll actually see square root of x looks something like this. And we're looking for what is this yellow highlighted region right there. So here is my g of x. So here, again, I'm not given an interval to work with. So I'm not given an interval, so that means I need to find where these two functions intersect. It looks like they intersect right here at 0, and that's one you could probably go and check. But what is this other point right here? What is this x value? So I'm going to take x squared, set that equal to square root of x, and solve for x. This one's a little bit tricky, I think, to solve. It's not quite so straightforward. I don't like square roots, so I'm going to get rid of that first, and the way I'm going to do that is I'm going to square both sides. X squared squared, when I have a power raised to a power, we multiply those two, so I should have x to the fourth is equal to x. Now be careful here. You don't want to divide by a variable here, because that means you're going to lose out on a root. You're going to lose out on a solution. So what I'm going to do instead is I'm going to set this equal to 0. So I'm going to subtract x from each side. It'll give me x to the fourth minus x is equal to 0. And now I see, hey, both terms on the left-hand side, those are factors of x. I can just take x out from each factor. That'll leave me with x cubed minus 1 is equal to 0. And so I have two solutions. The first is just x equals 0, which that one we said, okay, we're going to have that one for sure. The other one I have x cubed minus 1 is equal to 0, which gives me x cubed equals 1. If I take the cubed root of each side, I end up with x equals positive 1. So that is my other point of intersection, x equals positive 1. So here, when I set up my definite integral, I know I'm going to be integrating from 0 to positive 1. Now I just need to determine what is my upper function and what is my lower function. So again, if you need to draw in that vertical line, I do think that helps you determine what your upper function is. Here, my upper function, the ceiling of that region, is the blue function g of x, which is square root of x. So let's write that as square root of x, minus my lower function is the black function f of x, that is x squared dx. So I'm just trying to evaluate this definite integral. And I know I'm going to want to integrate square root of x, so I'm just actually going to take a second and say, you know what, let's just write that as x to the 1/2 right away. So let's see, I want to find my antiderivative first. That would be x to the 3/2 power multiplied by the reciprocal would give me 2/3. Minus over here, I should have x to the 3rd over 3, or 1/3 x cubed, evaluated at 1 and at 0. So let's see, I should have 2/3 times 1 to the 3/2 power minus 1 cubed over 3 minus 2/3 times 0 to the 3/2 power minus 0 to the 3rd over 3. Here on this right-hand term, 0 to the 3/2 is 0 times 2/3. That's just going to be 0. And 0 to the 3rd is 0 divided by 3 is 0. Be careful with this. This is just a friendly public service announcement. Don't always assume that that if you plug in 0 to your function or your antiderivative, you're always going to get back 0. That's a very easy way to make a mistake. You do need to take that x equals 0 and plug it in just to make sure. If it's a polynomial, yes, but if it's anything other than that, then we cannot make that assumption. So just be careful, make sure that you're not skipping that step. So let's see, 1 to the 3/2, that's just 1, so I have 2/3 times 1. Oops, 2/3. Oh boy, this is just a mess. 2/3 times 1 minus 1 cubed is 1 over 3, 1 over 3. So I'm left with 2/3 minus 1/3 gives me 1/3. So the area bound by those two functions is 1/3.